Today's lesson's about parabolas. Now, we've done parabolas before, but not in terms of conics. So our equations today dealing with parabolas have h and k's in them, like the equations for circles and ellipses. Okay, so our circle was what? X minus h squared plus y minus k squared equals r squared. And h and k were the center. Our ellipse was x minus h squared over a squared plus y minus k squared over b squared equals 1. H and k was also the center on that one, and a was the direction in the x direction, b is the direction in the y direction. And you drew your ellipse, okay? And we also had definitions for them in terms of distance. We can do the same thing for a parabola. Okay, first I'm going to erase these. We don't need them. Let's not get our notes confused. Okay? It says a parabola is a set of all points x, y in a plane such that are equidistant from a fixed line, the directrix, and a fixed point, the focus. The midpoint between the focus and the directrix is the vertex. The line passing through the focus and the vertex is the axis. So down here I have a picture that this is the focus. Okay, so that's the focus. This is the directrix. The distance from here to here is the same, because that's the definition, that any point on the curve is going to be equal distance from the directrix and the focus. But that's going to be true for this point also. The distance from here to here and here to here are the same. Or the distance from here to here and here to here are the same. So you can tell I did a bad job of drawing that picture. Okay? But that's what the definition says. All those points are equal distance from the focus and the directrix. Dang it, I lost my picture, so let me put my picture back. And that one, okay? So there you go. And it doesn't matter if it opens sideways or up and down, which we've done that before. Okay? So here's your equations. Usually, we have a y equals and you have an x squared. There's a leading coefficient that tells you whether it opens up or down. If it's positive, it's up. If it's negative, it's down. And it also tells you how flat it is or how steep it is. All right? And then this was the vertical shift. But we can rewrite that equation by multiplying both sides by 4p, but you go ahead and subtract your k first. So now I have an x minus h here and a y minus k here, so that it matches circles and it matches ellipses. The ones that open left and right, same thing. I can subtract h from the x and multiply by 4p. Now I have the squared term equals the not squared term, which is opposite of this one. Here's the squared term and that one's not. All right? It's 4p when it's with the not squared term. 4p, not squared, or it's 1 over 4p if it's with the squared term. And that's important, because p, okay, p, put that right here, p is the distance from vertex to focus, or vertex, put an or in there, vertex to directrix. That's what P represents, okay? So let's get rid of all these. Just remember that 4P goes with the non-squared term. All right, I'll stop being... All right, so it opens up or down, positive or negative. That's not new. It opens left or right. It's right, positive, left, negative. HK is the vertex. To find the focus, when it's a vertical opening up and down, you're adding it to the y value and subtracting it from the y value. When it's opening left and right, you're adding it to the x value, which makes sense. I graph it first and then I figure out the coordinates, because that's the way my brain works. LR, there's a good word for you. It's called the lattice rectum. Okay, everybody gets to laugh now. We just shortened it to the LR, so everybody stops laughing and calling it the lattice rectum. it's the length of 4p. And why do we need that? It was a good way to graph. I'm going to have to look that up. The axis of symmetry runs right through the vertex. Okay? But anyway, the distance here is p. 636. Hang on, I'm looking something up. There we go. I think I'm right. Yeah, because you're adding p. So there you go. All right. So let's go on. It says sketch a graph and write the equation of the parabola with the directrix at y equals 3.75 and the axis of symmetry is x equals 3. Axis of symmetry, remember, runs down the middle. So if that's at x equals 3, it's going like this. And my parabola's got to be opening up and down. Okay? Now, the directrix is at y equals 3.75. So this is really tiny. 1, 2, 3.75. And the focus is at 4.25. My vertex has to be in dead center in between them. So it's got to be at 3, 4. Okay? So you know it's x minus 3, and you know it's y minus 4. We know it's opening up because your axis of symmetry is vertical, so it's going this way. So this has to be the squared term. And all I need is my 4p. Well, 4p goes right here. Remember, p is the distance from vertex to focus, which is 0.25, which is 1/4. Okay, so 4p is equal to 4 times 1/4, which equals 1. So the equation for this parabola is x minus 3 squared equals y minus 4. If you want to put it in the other standard form like we used to see it, you can move the 4 over to this side and you end up with y equals x minus 3 squared plus 4. There's your vertex. It went up 3. It's going to go this way. You plug in some x and y values and you can graph it. Okay? All right, let's do another one. Identify the important components. So the important things we need are the vertex, the focus, the directrix, oh, I know what the latus rectum is. I remembered the latus rectum. It's the distance through from here to here. This is LR. You go through and the points on the end of it. So if you go up to here to your focus and then over 2 this way and over 2 that way, because let's say it was 4, you've got points for your graph. So on this one we've got here, 4p is 1. This is such a mess. 0.34. If I go up a quarter and go a half this way and a half that way, those are 2 points that are on the curve. I remember that now. Usually the numbers are so small it's hard to graph that way. There's a few that it works for. Oh, I'm glad I remembered that. All right, vertex, focus, directrix, latus rectum. Okay, I think and it might ask for the axis of symmetry. Okay, if I change this equation, it could be y minus 4 equals 1/2 x minus 3 squared. So my vertex is at 3, 4. Okay, this is with the squared term, so 1 over 4p equals 1 over 2. So 2 equals 4p, so p is equal to 1/2. So I'm going over here, 1, 2, 3, 1, 2, 3, 4. There's my focus, my vertex. It's opening up because it's an x squared, so my focus is above it, so you're adding it to the y, so you get 3 and 4.5. The directrix is going to be underneath it, so it's 3, 3.5. The length of the latus rectum is 4p, so, oh, dang it. So that's 2. The axis of symmetry is x equals 3. Okay, so I can go up here, plot that point. If I go 1 this way and 1 that way, my curve's going to go through that. That's just peachy. These are just teeny tiny graphs, and it's not very helpful. Okay, here's another one. We've got a y squared. This is negative. So you know it's opening left. Okay, so my vertex is 1, negative 2. So 1, negative 2. Okay, I know I need my focus and my directrix. Well, this is negative 8 equals 4p because it's with the not squared term. So p is equal to negative 2. Well, negative 2 backs me up this way. So 1 minus 2 is negative 1. So this time the x value is changing. And my directrix is over here. So 1 plus 2 gets me to 3. Okay, my axis of symmetry is y equals negative 2. Just going this way. My LR is equal to negative 8. Okay, so that means I can come over here to my focus. I can go 1, 2, 3, 4 that way, and 1, 2, 3, 4 that way. And my graph is doing this. See, it's helpful on that one. If you move this the other way, so the way we usually see it, you'd have x minus 1 equals negative 1/8, y plus 2 squared. And then we'd actually move this to a plus 1 over here instead. So this would be x equals. And the negative 1/8, you know it's a flat graph, right? Okay, let's do the next one. Write the equation of the parabola with a vertex at negative 3, 4 and a focus at negative 3, 2. I have to graph. My brain just doesn't function without it. So 1, 2, 3, 4. So here's the vertex. The focus is at negative 3, 2. So it's telling me my graph's doing this because the focus is always inside your parabola. Okay, so the distance from 4 to 2 is 2. So p is equal to 2. It's an x plus 3, and I have y minus 4. It's a parabola opening down, so this is the squared term. So this side has to have a negative 8, or it's a negative 1/8 x plus 3 squared. Okay, either way, both equations work. Your directrix then is going to be up here at 6. Axis of symmetry is this way. The lattice rectum is 8, so I'm here. You go 4 this way and 4 this way, and my curve's doing this. Isn't that fun? All right, last one. We've got to complete the square. I've got an x squared, so you keep the x terms together. You put a box in to complete the square and move everything else to the other side. Half of 2 is 1, 1 squared is 1. So I add 1 there and I add 1 there. This is x minus 1 squared. This is negative 8y minus 8, so that's negative 8x plus 1. Oh, good, it's a parabola that's squared, it's negatives, it's opening down. My vertex is at 1, negative 1, 1, negative 1. Nope, I went the wrong way, 1, negative 1. 4p is equal to negative 8, so p is equal to negative 2 again. So it goes down here. The directrix is here. Okay, so directrix is y equals 1. Focus is 1, negative 3. LR equals 8. What else do we need? Oh, axis of symmetry is x equals 1. And so I come here and I go 1, 2, 3, 4. 1, 2, 3, 4, and my curve is going like this. Isn't that peachy? Nice way to graph. Alrighty, that's all I got for you. Go practice.